So, my dear students, in the last class, we just started with the projection of solids, and also we just discussing one or two problems in the last class. Okay, so I think we started with the projection of prisms. Okay, so we solved I think the three problems in the last two classes where we discussed how to solve the problem on square prisms as well as one problem on pentagon. Okay, so I have taken different cases, that is solid resting on HP with the edge resting on with a corner in the square, and also we have taken one problem on the pentagonal prism also. Okay, so in today's class, I will going to teach how to do a problem in solids while beta angle. So how to take beta angle in solids. So we discussed what is beta angle in the case of a laminars. So in the case of a solids, how we can take the beta angles, and that we will going to discuss. So we take one simple problem now, and we are going to start that problem. So hope you people can start simultaneously. You can do it on your sketchbooks also. Okay. Yeah. So we'll take the problem. So if you find any problem in displaying the questions, please stop me and you can just ask me. Okay. So we'll take down the problem. A pentagonal prism, 25 millimeter sides of base, a pentagonal prism, 25 millimeter sides of base, and 50 millimeter axis length. 50 millimeter axis length rests on HP, on one of its corners of the base, such that the two base edges containing the corner, on which it rests, make equal inclinations with HP. Draw the projections of the prism. When the axis of the prism is inclined to HP, when the axis of the prism is inclined to HP at 40 degrees and to VP at 30 degrees. So this is the problem on a pentagonal prism. So what does it says is a pentagonal prism, the base side is 25 millimeter and the axis length is 50 millimeter, and it is resting on HP, and it is resting on one of its corners of the base. So this is very important. When they say a solid is resting on one of its corners of the base on HP means, so we are going to start with the top view. So in the top view, you can see the true shape and the true size of the pentagon. So because pentagon is the one which will be at the base and the face. So we can see the top view as the pentagon, and the true shape and true size of that can be seen in the top view. So you have to start with the top view by constructing a pentagon of size 25 millimeter such that the corner should come to your right. Okay, because it is a pentagon, so pentagon will have an opposite edge and opposite corner. So therefore, the corner and the side will be opposite to each other. So therefore, while you are resting a pentagonal lamina or pentagonal prism on HP, such that the corner should be on HP. So you will going to start the top view by constructing a true shape and true size of the pentagon such that the corner should come to your right. Okay. So corners of the base such that the two base edges containing that corner makes equal inclinations with HP. Draw the projections of the prism when the axis of the prism is inclined to HP at 45 degrees. We inclined to HP at 40 degrees and to VP at 30 degrees. So now what we will do here is, so we're going to start the problem. So in this problem, what they have given is, so the initial position is just constructing a pentagon with a 25 millimeter size of base and resting on the corner, and that front view will be the axis length of 50 millimeters length, and we're going to construct the top view and the front view. And in the second position, what we see is the axis of the prism is inclined to HP at 40 degrees and to VP at 30 degrees. In the case of a solids, so when you get an axis is inclined to both HP and VP, when the axis is inclined to both HP and VP and the word appears is not present. So in the previous problem, I think in the last problem what we discussed in the Saturday's class, so I think the word appears was there. So therefore we have not taken the beta angle there, and we just constructed, we just completed the projection by just inclining the axis with respect to HP and VP as usual, and we have got the final projection. But in this case, what we see is the axis is inclined to both HP and VP. So when the axis is inclined to both HP and VP, then the problem will be a candidate beta problem. And also you have to look it out for whether the word appears is not there or not. If the word appears is not there, then definitely it is a beta angle problem. Okay, so in this problem, what we are getting, the axis is inclined to HP at 40 degrees and to VP at 30 degrees. So inclined, the axis is inclined to both HP and VP, and also the word appears is not there in the problem statement, and hence this is, but definitely it is a beta angle problem. In the sense, we have to complete the projection by taking a beta angle in the third position. Okay, so the same thing, same procedure how we follow for the laminas, the same thing will also applicable in the case of a solids also. Okay, so how we constructed the beta angle, so how we determine the beta angle, same thing we also have it here. So same thing we need to get the things done here also. Okay, so let us start projecting the problem here. So please draw in your sketchbook or a sheet of paper. Please practice it. Okay? So one important information what we received from V2U is all the syllabus should be completed by 31st of May. Okay, so once you come to the college, so immediately you will be having examinations. Be careful, be careful. Okay, so this is what we received yesterday circular from VTU. So syllabus should be completed by 31st of May. So that's what I am telling you from the books. Please complete the sketchbooks. Don't keep anything incomplete. Okay, so once the college reopens, so only you will have a few days time, maybe a week or 15 days or 20 days time. By that we have to cover everything what we have discussed through online. Everything has to be covered in the classroom, and it has to be completed for the students. So you don't find much time to complete the sketchbooks during that period. So please, you are free now. Please complete and keep it with you. Okay, once you come to the college, only just to brushing up the things. So wherever you have clarification, wherever you have doubts, that will go to clarify and we will go to complete the syllabus. Okay. So please, I want everybody to start doing these things as I just go ahead. So because we will have 1 hour, for we take around 40 to 45 minutes for 1 hour. So I think that is more than enough for you to complete the sketching. Okay. So this is the problem statement what we are having. So now, as usual, how we do? So when a pentagonal prism is kept over a horizontal plane such that it is resting on one of its corners of the base. So when you just see that pentagonal prism from the top, so you can see the true shape of the pentagon. So that is the true shape of the pentagon in the sense the top face, what we are having. The top face is the pentagon, and even we have a base is also a pentagon. So you can see from the top as a pentagon, the true shape and the true size. So that is what we are writing over here. In this case, you construct a pentagon of 25 millimeter side. This is the top face, what you can see from the top view. Okay, such that the corner should be on the right side of you. Okay, so you just construct like this. So this is how the pentagonal lamina should be constructed, and be careful that that pentagon, the corner should be to your right. Okay, so this is the initial position top view, and also we need to satisfy that the corner, the edges which contains the corner will make an angle of 45 degrees with respect to HP. So this how do you construct it? See, the corner is, we are having the corner is C1. C1 is the base corner, or C1, whatever it might be. So the edge which contains that corner will be C1 D1 as well as C1 B1. Or of course in the top view, or in the top face, you can say CD and CB. So we have to satisfy the condition that the edge which contains those corners makes equal inclination with respect to HP. So this is not necessary to show. Only thing you have to know these things, how we can satisfy the condition. So see this edge, what I am talking about, the edge what I am showing here, that is C1 or CD. So when you just project it back slightly towards the XY line, okay, so it should make a 45 degree. The angle, if you just extend this line to tilt the XY line, that is CD or C1 D1, so that should make an angle of 45 degree with respect to HP. And also the another one edge, which is C1 B1 or CB. So when you extend it back to the XY line, it should make a 45 degrees with respect to the XY line or HP, whatever it might be. So this is how you satisfy the condition, not necessary to show this, but when you construct this in this similar way, in the regular way, so if you are taking the two different methods, so I taught how to construct a pentagon. So if you construct in that particular way, definitely it will satisfy that condition. But for your conformance, you can just project it back and check whether the angle is 45 degrees with respect to HP. So this is the top view of a pentagonal prism resting on HP with one of its base corners. Okay, so the top face will be A, B, C, D, E, and whereas the bottom base will be A1, B1, C1, D1, and E1, and it is the solid is resting on the base corner, which is nothing but the C1. C1 is the resting corner. Okay, so now this is the top view where the base cannot be seen in the top view. So therefore, all A1, B1, C1, D1, and E1 has been represented in the parentheses. Okay, so this is the top view of a pentagonal prism resting on one of its corners of the base on HP. Right? So in particularly, of course, then you can get what is the front view for this. Just draw the projector lines, and of course, I told you to get the axis line. So how do you get the axis line? So in the case of a pentagonal, so you have to draw minimum 3 perpendicular bisectors. Okay, a perpendicular bisector is the one which is a line which joins the corner to the midpoint of the opposite edge. Line which joins the one corner to the midpoint of the opposite edge. So just you have to draw minimum 3 perpendicular bisectors of a pentagon, and you have to locate the axis reference point. Okay, so you can join from any 3 corners. So you have to draw a very thin line, very thin line, such that all these 3 perpendicular bisectors meet at a common point. So that point is a reference point for us to represent the axis of a solid. Okay, so let us take O is the point of the axis on the face, whereas O1 is the point of the axis on the base. So O1 is represents the axis. Okay. So in a similar way, so you can project it to the front view by just drawing the vertical projectors till the XY line. Okay. So but the axis what you projecting here. So the axis length they have given it as 50 millimeters, but here it has shown 60 millimeters. So it is only a you can take 60 only, no problem. 60 or 50, I think in the statement they have given 50 millimeter, but here they have shown 60. Whatever it may be, you can take 50 millimeter or 60 millimeter, I think not an issue. And you can just represent the axis length as 60 millimeter. So draw a line, project a line for 60 millimeter above the XY line. Okay. Then what you can see in the front view. So when you see a pentagonal prism in the front view, that is in this direction, from this direction, so you can see the two rectangular faces of the pentagonal prism. What are the two rectangular faces are? One is A, B, base B1 and the base corner A1. A, B, B1, A1 is the one rectangular face which can be seen in the front view. Similarly, you can see another one rectangular face which is nothing but B, C, bottom C1 and the bottom B1. So B, C, C1, B1 is the another one rectangular face which can be seen in the front view. So therefore, so once you draw a top view of a prism, so you should be in a position to have in your imagination that when that prism has been seen in the front, so we can see the two rectangular faces of a prism. So that is the front view. So where you can see this pentagonal prism, the front view, when you just project it back to the XY line, so you can see this is the one rectangular face which is A dash, B dash, B1 dash and A1 dash. This is the one rectangular face, and the other one rectangular face is B dash, C dash, C1 dash and B1 dash. So this is the other one rectangular face. So these are the two rectangular faces which can be seen in the front view. Okay, so therefore you can see here A dash, B dash, B1 dash and A1 dash. So this rectangular face, they are not represented with a parenthesis. Similarly, B dash, C dash, C1 dash and B1 dash. That is also not in the parenthesis, means that particular rectangular faces are seen or can be visible in the front view. So project it back, so you can see all these projector lines. See, we have A dash, this is A dash, this is B dash, C dash, D dash and E dash. So that will correspond to the pentagon, the top face of a pentagon. Whereas across the bottom base, we have A1 dash, B1 dash, C1 dash, D1 dash and A1 dash. So this total height or the axis length of the prism will be 60 millimeters, and you can construct this. This is the front view of a pentagonal prism resting on HP with one of its corners of the. I hope you people are following. If you have any clarification at any point, you can stop me. Hope you people also doing in your textbooks or Inclination paper. So please do this. So unless you practice, definitely it is very difficult for you people to do it in your exams. Okay, so please, I request everybody to simultaneously please keep on doing. Then only once you start doing, then only you will have a lot of doubts. If you don't do anything, so there will be no doubt, and ultimately you need to suffer. Okay, so I request everybody please keep on doing this. Okay, so that it will be easy for everybody, for you people at the end. Okay, so please type your ESN in the chat box, name and ESN, that will be taken for your attendance. Okay, please type, don't forget that. Okay, I hope everybody is doing that. So any clarification, you can stop me at any point and you can have your doubts clarified. Okay, so I will continue. So I hope this is the initial position, of a pentagonal prism resting on one of its edges of the base on HP. So once you complete the initial position, and of course you have to draw the axis also. Axis is O dash is the point at the top face, whereas O dash is at the point of the axis on the base. So now the second thing is, so this pentagonal lamina is inclined to HP. The axis of the lamina is inclined to HP at 40 degrees. Yeah. So the same thing, how we did the problems in the previous classes, same procedure here. Only thing is the third position, I need much explanation is required for you. So what you do, the inclination of the axis of the solid is 40 degree with respect to HP. That can be shown. So how you can do, you will go to tilt the solid. You will go into tilt the solid such that the axis makes an angle of 40 degrees with respect to HP. So how do you start that? So I will keep on telling you from the solid. So because you are tilting such that the corner should be on HP. So how do you say, how do you satisfy that? You are tilting the solid in such a way that, so the corner, the base corner, that C1 should be on the HP. So that can be satisfied by just representing the C1 dash on the XY line. The base corner is C1 dash. So C1 dash should be on the XY line. So that is a very much mandatory condition that needs to be satisfied. So if you make this C1 dash above or below the XY line, so entire, starting from the second position, you will be able to get the 0 marks. The problem will be treated as a wrong and you will be given 0 marks for the entire from second position on. So be careful that the base corner should be on HP. So that can be satisfied, making that the C1 dash is the base corner here. C1 dash as a base corner, which is to be represented on the XY line. So therefore, how to make that is, first you mark a C1 dash on the XY line. First you mark C1 dash on the XY line. Take a convenient distance from the initial position front view on the XY line. Mark C1 dash. Okay. So first you can draw the edge C dash and C1 dash first. So how do you draw this angle? So when you incline that entire solid with respect to HP by making an angle 40 degree with respect to the axis. So the axis and this lateral edge, that is C and C dash, are parallel to each other. Parallel to each other. That is C dash and C1 dash is parallel to O dash and O1 dash, the axis. So therefore, when you want to satisfy the axis inclined to HP at 40 degrees, means the edge C dash and C1 dash should also incline to HP at 40 degrees. So therefore, what you can do here is, first you draw this edge. Okay, that is C dash and C1 dash, such that C1 dash should be on the XY line. So therefore, first what you do is, first mark C1 dash on the XY line, anywhere on the XY line. So take a convenient distance from the initial position front view, mark C1 dash on the XY line and draw a line C1 dash and C dash of the length of 60 millimeters, and that line should be inclined to HP at 40 degrees. So draw a line for a 40 degree inclination of a length for 60 millimeters that represents C1 dash and C. Okay, if this is inclined means, and then of course we can show the axis also inclined to HP at 40 degrees later on. But here don't show the angle for 40 degree with respect to C dash and C1 dash. But what we want to show is axis is inclined. Okay, so once you get C1 dash and C dash, that this line which is inclined 40 degrees, okay, then you can construct the outline of the front view. So how do you do that? So C1 dash and C dash is already drawn. So now C1 dash and A1 dash. So this you can get it. C1 dash and A1 dash. So you can get this is a 90 degree because this is the 90 degree. So you can take a 90 degree with respect to C1 dash and you can draw this base also. This base can also be drawn, so which makes an angle 90 degree with respect to C1 and C dash. So you can just draw this line. And once you get this line on all the outlines, first you draw the outlines, then you can draw the inside lines. That is easy for you. Okay. So now this entire initial position front view should be transferred to the second position front view such that the axis is making 40 degree with respect to HP. So this is the second position how we will go into transfer it. This figure, this front view and this front view are same. Only the change here is the axis is inclined. The solid is tilted in such a way that the axis makes making an angle of 40 degree with respect to HP. This is how you can construct the outline first, and correspondingly you can get these points C1 dash and B1 dash. So C1 dash and B1 dash, take a compass, measure this distance and cut here, and you can join. And similarly the axis also. So take the distance from C1 dash to O1 dash, so mark here, and C dash to O dash, mark here, and then you can join. So once you get the outline of a front view, then correspondingly taking a measuring the distances with a compass from the initial position front view, and the same points can be transferred in the second position front view. So this is what you can show, and after completing all the lines, so what you have to do, you have to extend the axis line till the HP, and you can show that angle is inclined, that axis is inclined 40 degrees with respect to HP. That is what we want. Don't show here. The C dash and C1 dash don't show. Only thing is O dash and O1 dash should be shown there. Okay. So this is the initial position, second position front view representing the axis inclined to HP at 40. Correct? Hope people are following. Okay, so please, if you have any clarification at any point, please stop me. Okay. Next, once you complete this, next thing is we have to get the corresponding top view. So obtaining the top view is just drawing the projector lines. Draw the projector lines from each and every point of the solid. Okay, so we are drawing the vertical projectors, including the axis you have to draw, and even the base. From there also you have to draw the vertical projectors. Totally in this case you are going to get 1, 2, 3, 4 in the top face, and in the base also you are going to get 4 vertical projectors. Totally 8 vertical projectors will be there, and the same thing you have to get it from the horizontal projectors from the initial position top view. Draw the horizontal projectors from the initial position top view. Okay, so you can get this. And now, so as usual, so mark the intersection points, intersection of vertical projector with the horizontal projectors. Okay, mark the corresponding point. Look at the corresponding point, because here it is both A, B, C, D, E, and A1, B1, C1, D1, E1. It looks all are same here. So the vertical projects are horizontal projectors are same. Only 5 lines you will going to get from the initial position top view. But correspondingly, where you are getting the vertical projector from the front view, so mark those points. See, this is A dash, the vertical projector from A dash, which meets the horizontal projector from A. So this is point A. Similarly, look at here, the same horizontal projector meets the base corner A1 dash. So remember always A dash and A1 dash should come on the same line. B1 dash and B dash should come on the same line. C dash and C1 dash should come on the same line. Like that, you should be very careful, because it is just what we call it as the transverse edge. Okay. So correspondingly, you mark first. You mark the points. Then you can apply the rules of visibility. Okay, for which sides are visible, which are not visible for us in the top view. Okay, so this is the one thing you should be very careful. So you are observing the solid in this position from the front, in the front direction. So when you see from this direction, so complete the top face is visible for. So top face is a pentagon, right? So pentagon is A, B, C, D, E. A, B, C, D, E. The top face is completely visible in the front view. So you can say the top face is should be shown as a continuous decline. right? Similarly, the edge which is nearer to the observer is A dash and A1 dash, A dash and A1 dash, and also E dash and E1 dash. That complete rectangular face is visible in the front view. So A dash, A1 dash, E1 dash, and E dash. That is a rectangular face which can be seen in the front view. See, here is this 2 points represent, it is an edge. A dash and E dash and A dash, A1 dash and E1 dash. So that will constitutes a one rectangular face. So this rectangular face can be seen in the front view. So you have to get this rectangular face as a continuous incline. Okay. So next comes, so which are the points which are away from the observer? Second important thing. So the most important point is the corner, the base corner, which is resting on HP, which is away from the observer. So I think in the last classes, I think I might have explained. So very simple way is to represent or to show the invisible edges is look at the point or the look at the corner or the edge which is away from the observer first, and the edges which arises out of those points should be considered as an invisible edge, okay, if they does not form an outline. If it does not form an outline. So this is a very simple logic, a very simple way where you can represent the invisible edges in our solids. Okay. So now what's happening? The C1 dash is the corner which is away from the observer, and very simple way you can say the edge which comes out of or which arrives out of C1 dash. Which are the edges which comes out of C1 dash? One is C1 dash and C dash. This edge definitely it is away from the observer, and the other two edges is C1 dash and B1 dash, and C1 dash and D1 dash. So because C is the in-between point between B and C, B and D, sorry, B and D. So therefore, C will have share a common corner with respect to the two edges. One is a B1 C1 and C1 D1. So therefore, those two edges are not visible in the front view. This is how you should imagine. So before you should draw it on a paper or whatever it might be or in a system, so you should be in a position to know what edges are not visible. So these are purely it is imagination. Okay, it is purely imagine. You should imagine this is what's happening. We cannot see that. So that once it comes into your mind, then it is easy for you to represent it on a paper. Okay. So before you represent, you should have it in your mind. You should imagine. So this is what I am getting. This is what I cannot see. This is the invisible edge. So this is the corner from which the two edges will arise out. And those two edges also cannot be seen. This kind of imagination thought should come to your mind. Then you can represent it on a sheet of paper. Okay. So therefore, C1 dash is the corner which is away from the observer, and the edges which arises out of C1 dash are definitely an invisible edge. So that is the thing what you're supposed to remember, right? So now we have got in our, before you draw, the complete top face is nearer to the observer and hence it is completely visible for you. And the rectangular face A dash, A1 dash, E1 dash, and E dash. It is also nearer to the observer and hence it is also visible in the front view. So only the edges which comes out of C1 dash are away from the observer and they cannot be seen, and hence they can be considered as an invisible edges in the top view. Okay. So now we are representing the top view over here. So what you can see here, see A, B, C, D. It is a top face which is seen in the top view for you. Okay. Next, C1 dash, the edge which is away from the observer. So C1 dash, C, C1 dash, D1 dash, C1 dash, and B1 dash. These two edges are not visible in the top view. Okay. So now remaining. So look at the remaining edges here. So A1 dash, A1 E1 is an outline, A1 B1 is an outline, B1 B is an outline, Of course, this is completely visible. D1 is an outline, D1, E1 is an outline. So therefore, whether they are visible or not visible in the top view, so you have to show it as a continuous equation. Okay. So then join, suppose A1, A, E, E1 is visible in the top view. So therefore, that will go to form the complete rectangular face of visible edge. This is how you are going to apply the rules of visibility. So for showing both visible and invisible edges. I hope you people are following. Okay, so second position top view. So you will going to get the invisible edges. Okay, and of course the axis representation has to be done here. They are not shown the axis. You have to show the, of course they are shown. They are shown the axis over here. The axis is shown here. So O1 dash and O dash. This axis. Okay. So now the length of this axis O and O1. O and O1 in the second position top view is a foreshortened length of the axis. So the original length of the axis is 60 millimeters. Since it has been inclined in the second position with respect to HP at 40 degrees, and you are observing that solid or that axis in the top view, and what you will going to get, the length of the axis in the second position top view, that is O1, should be always smaller than that of the original length of the axis, which is O dash and O1 dash. So now the axis is already inclined to HP at 40 degrees. And in the same position, so you are tilting the solid such that the axis, which is foreshortened, makes an angle of 30 degrees with respect to VP in the third position. The foreshortened axis is tilting with respect to VP at 30 degrees, and hence the angle what that solid is inclined is not exactly 30 degrees, it is more than the angle of 30 degrees. So what is the angle that is actually inclined is nothing but the beta angle. Okay, so we have to determine that what angle that the solid is being inclined with respect to VP actually. This is what the beta angle corresponds to. Okay, this is what I explained, the how beta angle should be considered and what is beta angle in the projection of plane surfaces. The same concept is also applicable here. Okay. So now I hope you people understood how to draw the second position top view. Now we have to move to the third position. This is a very important position for us. So why? Because so this is where the concept of beta angle will come into the picture. So where we will going to show the beta angle. So how do you do this beta angle, this construction? Please listen carefully. Okay. The procedure remains same, but only thing is axis you have to show as a inclination with respect to VP. So now in the second position top view, so we have the length of the axis as O1. So as I told you, this is a smaller in length, or it is a foreshortened length of an axis O dash and O1 dash. Whereas O dash and O1 dash, which is in the initial position front view, which is a 60 millimeter. The original length or the actual length of the axis is 60 millimeter, whereas once it is inclined to HP at 40 degrees, its length will be foreshortened. That can be obtained in the second position of view. So O and O1 is the foreshortened axis length of the solid. Now this axis should be inclined to VP. In the sense, we are going to tilt the solid. The second position top view will go into tilt in such a way that the axis O and O1 is inclined to VP at 30 degrees. Is inclined to VP at 30 degrees. So when you want to show this inclination, or when you want to incline the solid which the axis makes an angle of 30 degrees with respect to VP, then the concept of beta angle comes into the picture. And this is where you should show the beta angle construction here, right? So how do you do this? The same concept how we did in the previous. So what you do? So first you draw a line for 30 degrees with respect to VP. The angle of inclination what they have given with respect to VP is 30 degrees. Okay. So draw a line. Draw a line which is inclined to VP at 30 degrees. And please take a convenient distance below the XY line. So be careful because not even a single part of this top view should go above the XY line. So if any portion or even a small portion goes out of or beyond the XY line or above the XY line, then the third position will be considered wrong. So therefore, while you are doing solids, please take a convenient distance below the XY line, draw one parallel line to the XY line. From there you can measure the angle, no problem. Okay. So please make sure that the solid should not go beyond the XY line, it should not go above the XY line. So now first you draw a 30 degree line, okay, 30 degree line with respect to VP. On that 30 degree line, mark point O and O1. So first you mark point O on the 30 degree line, okay. So take a compass, measure the apparent length of the axis from the second position top view. Apparent length of the axis from second position. You take the true length of the axis from the front view, the initial position front view. The true length of the axis from first position, that is initial position top view. So from O dash, O, so mark a O1 of actual length. Mark O1 which is of 60 millimeter. O you know, take a compass. Set the radius equal to the actual or the original length of the axis, which is equal to 60 millimeter. With O as a center, cut the 30 degree line. Okay, cut the 30 degree line. So that point will correspond to O1 point. Okay, so once you get that point, okay, draw the locus line. Similarly, draw the locus line, the locus line which is passing through that point. O1, which is parallel to the XY line. It should be a very thin line you have to draw. Okay. So once you get the locus line, then take the compass, measure the apparent length of the axis from the second position top view. Take a compass. So once you get the locus line, I will explain how to get the locus line. First, you draw a 30 degree line with respect to VP. Mark O on that 30 degree line anywhere just below the XY line, 30 degree line, mark O and measure the original or the actual length of the axis from the initial position front view, so which is equal to 30 degrees. So you can use the compass. Now move to the 30 degree line in the third position with O as a center. You cut the axis, that is the 30 degree line, with the radius equal to 60 millimeter. Then you mark the point as O1. Okay. So from that point O1, draw the locus line. So how do you draw the locus line? That locus line should pass through that point O1 and it should be parallel to the XY line. So draw a convenient length for the locus line and you mark it as a O1. Now move to the second position top view. Second position top view. Measure the apparent length of the axis. Apparent length of the axis in the second position top view, that is O1. Take a compass, measure that. Now with that radius, come back to the third position top view. Now we have got O1 on 30 degree line. O as a center with the radius equal to the apparent length O1. With center O, the radius equal to O1 in the second position top view. Now cut the locus line. Cut the locus line. Draw the arc for the locus line. So that represents the actual O1 form. Now join O1. Have to join O1. So that angle, joining the O1 with the axis line, you will going to get the actual axis, that is the inclination of the axis of the solid. So now that you project it back to get the angle. So that angle corresponds to the beta angle. Okay. So the procedure will remain same. So first you have to take the actual length, mark the actual length of the axis on the 30-degree line, draw the locus line, then measure the apparent length of the axis from the second position top view, and with that O as a center, you cut it and then join those 2 points. Where that arc cuts the 30-degree line, join O to O1 and then project it back towards the XY line to measure the angle. So that angle measures or what we call it as the beta angle. And in this particular problem, the angle of beta should come 41 degrees. Okay. So this is the construction of beta angle. So now with this O and O1, that is the beta angle, the line which is inclined to angle 41 degrees, with that as a reference, you have to transfer entire pentagonal prism, the top view, the second position top view to the third position top view, taking the reference as O1. O1, which is O1 is a line which is inclined to XY line at a beta angle 41 degrees. That is the reference. Don't take 30 degrees. Take the line, the axis line which is inclined to VP at a beta angle of 41 degrees. So these two are the 2 reference points for us. With these 2 as a reference, then you have to construct or we have to transfer the entire second position top view. This means you have to construct this complete top view over here. Okay, so you can use compass method. Take a compass, convenient distance from each one, and you have to construct. That's what I told you in the last class, how to do this, how to transfer the second position top view to the third position. This is the place you should be very careful. Why? Because it is the one which will take a lot of time for you. The rest of things you will do. So this will take a lot of time for you people. Okay, so please practice this. You have to do it very fast and including that access points always access important projected particle projector each point including the axis, and similarly the horizontal projector from the second position front view. Okay, so this is the same common. Once you get this second position, third position top view, then just projecting to the front view with the each point including the axis. Okay. So once you get that, so vertical projector intersecting with the horizontal projector, so please mark the points first. So please don't join first. First mark the intersection point for the corresponding points. So once you mark, then it is easy for you to draw the lines, just applying the rules of visibility. So we just observe this second position, third position top view from the front. Okay, very simple. The base is completely visible because this mirrored observer base is A1, B1, C1, D1, and E1. So when your observer is here, okay, so So the base is completely nearer to the observer, and hence base is completely visible in the front. Okay, and also the rectangular face A1, A, B, B1, which is also nearer to the observer, that should also be visible in the front view. Only the point which is away from the observer is point D. This is the furthest point in this front view, furthest point from the observer. So that is point D. So simple way, again the same how I explained for the initial top view. So the edges which comes out of that point should be considered as an invisible edge. See here, DE is the one point, DC is the another one edge, and of course D1. D1, DC, DE. These are the two edges are not visible in the front view. So you can see here. See, U dash, E dash, D dash, C dash, and D dash, D1 dash. So these three edges are invisible because point D is the furthest from the observer. So there you can see the dotted lines, the dashed lines, the thick dashed lines that are representing the invisible edges. So since the base is completely visible, so join the A1, B1, C1, D1, E1 with a complete continuous line. Then we can see A1, B1, C1, A1, B1, A dash, sorry, A1, B1, B1, A1, B1, B and A is visible in the front view. So therefore, you can see completely joined with the complete continuous line. Then look out for the other edges. So they will be forming an outlines. See, C1 dash and C1 dash and C dash is an outline. C dash and B dash, it is an outline. A dash, B dash is an outline. A dash, E dash is an outline. E dash and E1 dash is an outline. E1 dash and D1 dash is an outline. So like this, you will going to get the outlines. The outlines, whether visible or not visible, either in the front or top, that should be considered as a continuous thick line only. They will be considered as a visible lines only, and you have to represent it as a continuous thick line. Got it? So this is how you will going to complete. Of course, you have to show the axis also. So please don't forget to show the axis here, O dash and O1 dash. So these are the 2 projected points here. So join those 2 axis points, O dash and O1 dash, with the axis line representation. So this completes the projection of a pentagonal prism resting on HP with one of the corners with axis inclined to both HP and VP. So this is the problem for a beta angle. Hope you people are understanding. If you have any clarification, so you can have. So any clarification, my dear students, if you want to talk to me, you can talk. So before we have around 5 minutes break, so I want you people to discuss with me for regarding any clarifications here. So if you have such clarification, please be free. Feel free. Yeah, anybody having any clarification here, please unmute your microphones and you can talk to me. So my dear students, I am just cautioning you, you don't find much time once the class starts. You don't find much time. So please complete the sketchbooks, keep it ready. Whatever the things we are doing now, please keep it ready. Because by 31st of May, we have to complete all the syllabus. Okay. And once you come to the college, maybe around 15 or 20 days time you might be having. So we're going to start with the classes. So you won't find much time because all these problems, especially solids, will take a lot of time. So please complete all these problems. Okay, so we will see if once the classes starts, only we will find time to revise the things. Not we cannot actually explain the things. We can revise the things and we can clarify the doubts and we can evaluate your sketchbooks. And of course, we can have provide a practice for you to do it on a system also. So I hope you people have practicing at home already. I just posted the Solid software in the Google Classroom. So please download it, install it, and then start practicing. Okay. So if you have any clarification, once you come to the college, so we're going to do it. Even if I do it in an online also, you will find difficult. So therefore, once you come to the college, we will have a practice session on all these things, and you can get a confidence. So one request is please practice it. Don't forget. So please practice it. Practice, practice, practice. Keep all your sketchbooks ready. By the time you come to the college, things will be easy for you. Okay. So we will take 5 minutes break. Okay. So it is 9:35. By 9:40, I will be coming back, and we will have another one problem we are going to solve. Okay. Take 5 minutes break. Please return back by 9:40.